Okay, I wanted to show you this skill factor polynomials with complex numbers. So it's a little tricky, factoring is tricky in and of itself, and then you add complex numbers in there, and it can be even trickier. So we have this expression 25x to the fourth plus 16y squared. We want to factor that. Okay, so I'm going to show you my solution, and then we'll just pick the right answer from among these. So this is how I work the problem. Okay. Um, right here, this would be a very factorable polynomial if we only had a minus in it. And if we had the minus there, it would be a difference of perfect squares, okay? Where we don't need any complex numbers to handle that situation, right? It would just factor, um, 5 is the square root of 25, x squared is the square root of x to the fourth, and 4 is the square root of 16, and y is the square root of y squared. So we just loaded up into the polynomials the same two things with a minus and a plus, right? And you definitely need to feel that. That needs to be, that needs to be familiar to you to really tackle these complex numbers. So if you need a little review on difference of perfect squares, what you can always do is just go to con and start hitting difference of perfect squares, and a lot of times it pre-populates, and you'll get, if you search for that, you get a bunch of stuff. Just hit like difference of squares intro here, and it'll give you this whole little section here on difference of perfect squares, where you can watch an intro video to it, do an intro practice, more videos, and then like a full-on difference of perfect squares practice, where you can practice doing it. And this is the non-complex version of it, right? But you really need to have this down before the complex one. Okay, so hopefully that makes sense. And then all we need to do is think about this as the sum, right? Which is plus. It's not difference. We have a sum of perfect squares, which in the past we haven't been able to factor. But now that we have complex numbers, we're actually able to do that. Okay. And you might want to prove this to yourself, because it seems like, well, you might be able to do it. Like, what if you just had plus and plus here? But if you FOIL this out, you're actually going to find that you get a middle term. You get the right stuff on the end. You get the 25x to the fourth and the 16y squared here, but you get stuff in the middle. Okay. Also, the same is true here. If we use a minus and a minus in our factorization, we still get the first term right and the last term right, but we end up with a middle term. So the solution ends up being, right, since neither of these work, is we can put an I into the factorization on the second term, and that's actually going to work so that we get rid of the middle terms, but also get the right stuff on the end. Okay, and it doesn't seem like that, because if you think about it, when you're foiling the L, or the last thing you foil, this is 4 times negative 4, which would give you negative 16. How is that going to wind up being a positive 16 here? Well, the best way to show you is just to actually FOIL this out, and I'll show you why this ends up resulting in this up here. Okay. So when we FOIL this out, we get the 25x to the fourth here. We get negative 20x squared yi, and then positive 20x squared yi, and then negative 16y squared I squared. Now you can see in the orange here, these two things are actually opposites. They just cancel each other out. This is why the middle goes away. And so we just have a 0 here. Okay. And then the I, by definition, I squared is equal to negative 1. So really the I squared is going to turn it into a negative 1 and multiply times this negative 16y. This is why we end up with this minus changes into a plus, and then we get exactly what we need for our factorization to be equivalent to the original polynomial. Okay, so I hope that helps a little bit. It's almost like a difference of perfect squares, except you gotta adjust with the eye. Okay, so let's just go back to our original problem and make sure con counts us right. Yep. So I hope that helps a little bit on a tricky skill.